work. In this video, we will use a lot of sensors explaining it and how it works and where it is used. Hope so you watch my videos without skipping. The first experiment is with HW531 sensor, which is a vibration sensor which detects vibrations. Now, this is how an HW513 sensor works. Each sensor has a number like 513 or 310 or 1 or anything. Now, I will show you how this sensor works. This sensor works it's a straight and the surroundings is all copper which attracts electrons which the electrons flow through it. When the string has electricity flowing on it, when it touches the copper plate, it sends electrical signals. Then it's showing vibration and it's work, and it will show to the board. It has 3 pins: signal pin, positive and negative.
Let's wire it up.
We will connect the sensor pin, signal pin, to a PWM pin 2 for this case. Then the positive to the 5 volts to give it power. And the negative to ground. Now connect the LED to indicate whether it's sensing or not. Connect the LEDs positive to P3. And the negative to ground. And our connecting is finished. When the sensor indicates a sensor, this LED toggles on or off depending upon the signal. If I press it one time, it's on, and again it's off. It's for unlimited time.
Coding time.
Description. Now, these are the connection: defined sensor pin and the LED pins 2 and 3. LED state is false. Last sensor pin high. Pinmode sensor pin input. Sensor pin is the input. Pinmode LED pin is the output, and the digital right LED pin LED state. We want LED state false and LED last sensor state high because to toggle whether it's on or off. See a digital right LED pin LED set serial begin 9600. Void loop if current sensor state digital read sensor pin. If last sensor is high and current sensor state low, LED state question mark. Digital right LED pin LED state. Then a serial brittle vibration detected a toggled LED. Delay last sensor states equals to current sensor state. Now upload the code. The last code means we are using current sensor state. You have to define that. What is that? So last sensor state is current sensor state. So like that.
Checking time.
I have uploaded the code for this vibration HW513 sensor. Let's test it out. When I vibrate it or touch it, the LED turns on. And when I again touch it, the LED turns off. It's depends on how the vibration. Like when I break the table, it's lighting off. When I beat it hard, it's turning off. And we can keep it there also. It detects vibration. The object moves vibration, so it's turning off. Next sensor we are using is this HW505, which is a tilt sensor. There is a ball or a liquid like this. This is a mercury which gives the electrons to flow. When it's in high, there is no electrons, means there is no signal. When there is like this, it has a rod and then another long rod, and the long rod passes electricity and the short rod receives the energy. When the ball is placed in the both, the electrons flow, so it gives the signal. When it's like this, it will not give the flow. We will use a tilt switch LED pin, like when it's like this, it's off, and this on.
Let's wire it up.
I will show you how to connect it. Take the three wires in the same order and place it in the, and I will say you a quick how to connect it. Signal goes to pin 2 and the red wire means the anode goes to 5 volts and the cathode goes to ground, negative or positive. Then the LED goes to 3 and the LED negative goes to the ground. Our connection is ready. Now let's code it.
Coding time.
Copy and paste the code that I left in the description. Now these are all defining the pins. Pin 1 tilt pin is input pull up, means uh, it's want to be an external pull up to avoid floating. LED pin is output, serial begin 9600. It tilt directed digital read tilt pin, digital read display 2 page 2. If tilt pin is low, means it's in the upper position. Digital writes LED pin high and serial print tilt on. In the serial monitor, it want to print tilt on and the LED wants to high. When it hits the lower bar, it's a low, so LED pin low, else means if it's low, then else means it will be high in this code. LED pin low till off, where it will print till delay 100 seconds. This loop forever. Then upload the code. You can check the serial monitor if you want to see the direction. It's working.
Checking time.
Now I have uploaded the code. As you can see, when it's in the lower, the mercury is in the lower, the LED starts to blink. When I flip it, the LED starts to turn off and it informs to the serial monitor also. And additionally, a LED light in here works when the electrons flow through. When it's not, the LED dot turns off. The next project we are doing is quite interesting. It's a laser alarm. This project laser alarm, we are using an LDR, which is the brain of our, which is the main use of our project because it senses whether the laser hits it or not. I have made that video in my channel about how LDR works, and we will use a laser to indicate like there is a light, a red light touching the surface of the LDR, and a buzzer to indicate there is no light in the LDR.
Let's wire it up.
Now let's connect. Before I talk, why I need this many dampened wires? Because we need more length. We need more length for the laser alarm to run. So we use this structure and connect it so it has length, not like this much length. So now let's connect it. Connect the ground of the LDR to the ground of the board on the negative to the ground. Then connect the positive side of the LDR to the 5 volts. We don't need pull-up resistor for this. LDR to 5 volts. Connect the signal wire to the D2 of or any PW pins, but you need to change the code. Now our connection for the LDR is fine, and don't disconnect the wires and make sure it is connected, otherwise it will not work. Next, let's add the laser. Connect the ground of it to ground, like ground to ground. Then the positive side. Positive side to the positive side to give it full connection. And here's the catch. You want to connect the positive to the signal also, because we are not adding signal for it. We are just giving 5 volts to it, so it is on forever. So connect the signal wire to the 5 volts. Now let's add the buzzer to the circuit to indicate there is no light, means there is someone in the laser. Connect the buzzer to the breadboard. The positive side to the 3 or any PWM signals, and the negative sides to the ground. If you don't have ground, connect it to the negative side and connect all the wire to the negative side like this, and connect the ground to the negative rail of the breadboard. It will be easier to connect. Now our connection is finished. Our laser alarm is ready to function.
Coding time.
Copy and paste the code that I left in the description. In LDR pin, T is the uh, connection. Buzzer pin is also the connection. Next, command above word loop. Pin mode LED pin is input. Pin mode buzzer pin is output. Serial begin in 9600. What loop is in LDR state. Digital write LDR pin. Serial print in LDR state means the LDR state is the digital read of the LDR pin, and serial print in the state means the it want to uh, print the LDR state. If LDR state is high, buzzer pin high. Like when it's high, the buzzer pin wants to be high. Digital pin buzzer pin low means if LDR state is low, means digital write buzzer pin also low. So like that. If high means high, low means low. After we have a delay for the not to continue, so we have a 100-second delay. Then upload the code. It's uploaded.
Checking time.
Now I have uploaded the code and assembled it. Now we turn lights off. Lights off. Now here you can see the laser is running. So when I touch it, the buzzer sounds on. The laser is going. When it's blocking. So it's working. Thank you for watching. I will make part 2 with more cool, awesome and many sensors. Hope so you like my videos, subscribe and share.